Hey everyone, and welcome to this explainer on behalf of Forge College. Grab your hard hats because today we are stepping right onto the construction site of our smart contracts to do some serious debugging. So in our previous lesson, Implementing Visibility in Practice, we laid down the foundational brickwork for how to restrict and open up access to our functions within our broader Solidity from Zero journey. Today, we're building directly on that. We are going to identify and fix 3 critical bugs related to visibility and parameter handling. We're looking at what the code is actually doing rather than what it just claims to do. All right, let's dive right in.
Now, think about this for a second. What actually happens when your smart contract's front door is left wide open? Imagine spending an absolute fortune installing this massive, impenetrable, high-tech steel vault to protect your life savings. But then, oops, you accidentally mount the hinges on the outside. Right? Anyone walking by can just pop the pins out and walk right in. Well, that is exactly what happens when you misconfigure function visibility and parameters in Solidity. You might have the absolute best logic in the world, but a tiny mix-up, that means external actors can manipulate your internal state, or your perfectly good data updates just vanish into thin air. Debugging these issues right now is absolutely crucial before we move on to more complex control flows.
Okay, here's our work order for today's explainer. Number 1, visibility mix-ups. Number 2, parameter mutations. 3, storage references. And 4, we're locking it all down with a rock-solid verification workflow.
Let's kick things off with bug number 1, visibility mix-ups.
Take a look at the buggy code here first. We've got our function helper increment, and it's set to public. Because it says public, it is part of the contract's public ABI. And guys, that is literally like handing a random stranger on the street the TV remote to your living room and just letting them change your channels whenever they want. They can call it directly and increment your counter completely unexpectedly. No way we want that. Now look at the engineering fix. By simply swapping that keyword to internal, we instantly remove it from the public ABI. It can now only be called from within the contract itself. If you still need outside users to trigger it, well, you build a controlled public wrapper function around it. That gives you a safe place to add access checks and validation. Basically, you keep the remote in your own hands.
Moving right along to Section 2, Bug 2, Parameter Mutations.
To really understand why those data changes suddenly vanish, we absolutely have to grasp this fundamental definition. Think of memory in Solidity as a sticky note. It's temporary data storage. You scribble something down, the function executes, and then boom, the sticky note is crumpled up and thrown in the trash. Storage, on the other hand, is like a heavy stone tablet. It is permanent contract data written directly to the blockchain. So when you pass a complex data type, like a struct, into a function using memory, you are only working with a sticky note copy of the data. If you mutate that copy, well, the original stone tablet remains completely untouched.
In our buggy code, the update record function tries to update record memory R. It is furiously scribbling changes onto a sticky note that gets immediately discarded the second the function finishes. Naturally, the change completely fails to persist to the contract state. To fix this, instead of taking a memory copy, we grab a direct storage reference. We are now pointing directly at the stone tablet itself. When we update the value here, the mutation actually sticks permanently to the persistent state. Much better, right?
All right, on to Section 3, Bug 3, Storage References.
Here's the deal. Returning a storage reference breaks the application binary interface, or the ABI. Handing out a storage reference to an external caller is exactly like giving a total stranger your original, one-of-a-kind master architectural blueprints. It's incredibly dangerous, it's just straight up not allowed for external callers, and it will absolutely cause compilation or runtime errors. What you want to do is hand them a safe, view-only photocopy. A function signature ending with returns record storage is that dangerous, buggy master blueprint handoff. We fix this by marking the function as view, since we're really just reading state here, and changing the return type to returns record memory. By specifically saying memory, Solidity automatically copies the struct from storage right into memory, producing a perfectly valid ABI serializable result that safely travels back to the external caller. No original blueprints at risk.
Okay, Section 4, our verification workflow. Because as engineers, you don't just guess that a contract works, you prove it.
Here's the rigorous workflow you should be using in Hardhat, Foundry, or honestly whatever framework you prefer. Step 1. Always reproduce the symptom with a failing unit test first. If you can't break it in a test, you can't prove you actually fixed it. Step 2. Apply the minimal code patch. Don't go rewriting the whole contract. Just fix that specific visibility or memory keyword. And Step 3. Rerun the tests. Seeing that failing test switch to a passing state is the ultimate confirmation that your contract state and return values now perfectly match your intent.
Let's quickly review our final quality control debug report, which perfectly summarizes our session today. For the exposed helper symptom, the root cause was an accidental public ABI, and our minimal fix was changing the visibility to internal. For the lost mutation symptom, the cause was modifying a temporary memory copy, and our fix was swapping that out to use a direct storage reference. And finally, for returning a pointer, the root cause is that storage references just aren't allowed externally, so we fixed it by returning a safe memory copy instead.
Before we wrap, I want to leave you with this absolute golden rule of Solidity debugging. Treat visibility as your public surface design, and be explicit about your data location. Are you handing out the remote control? Are you writing on a sticky note or a stone tablet? Are you giving away the master blueprint or just a photocopy? Keep these questions in mind, and you're going to be perfectly set up for our next lesson in the Functions and Modifiers module, where we'll dive into higher-level patterns that prevent these exact mistakes by design.
Thank you so much for hanging out with me today on behalf of Forge College. I really hope this explainer made debugging visibility and parameters crystal clear for you. Be sure to head over to forge.college to keep mastering Web3 engineering. But before you go, ask yourself this. If you audited your own smart contracts right now, how many master blueprints are you accidentally handing out to strangers? Go secure those front doors, guys, and I'll catch you in the next one.